Hi, welcome. So in this video I'm going to be compiling OpenSees and OpenSeesPy on a fresh install of Ubuntu. In this case I have a virtual machine which is has a fresh install of Ubuntu 22.04 Jammy Jellyfish. I just installed the VirtualBox add-ons and that's pretty much it. I don't have anything else installed. So we're going to do a from scratch install of OpenSees and OpenSeesPy using CMAKE files. And we're going to figure out the errors as we go, so that if you encounter the same errors or similar ones, you might get a glimpse at what it looks like to compile when you come up with errors. So it's a kind of a realistic and not just a simple tutorial. So we're going to fire up a terminal, Control-Alt-T for those new to Ubuntu or Linux in general. And we're going to start setting up a build environment. So we're going to do sudo in Spanish, apt install, and we're going to install the build essentials. So we're going to need the compilers. I want to make sure I have G4tran installed there, and I'm just going to go with the dependencies out of the top of my head. I'm going to be missing some. We want optimized linear algebra libraries, so we're going to install libopenBLAS. Let's see, libopenBLAS. If I double tap on tab, I can see the auto completion for the packages. So libopenBLAS, I guess it's going to be 64 dev. Yeah, let's go with that one. Let's get CMAKE, and we're going to get a whole bunch of things. Git, because we're going to download the latest sources. Let's see. Let's go from here. My password for the virtual machine. It's going to get some archives. And if this takes too long on my internet over here, I'm going to be doing some post-editing here. So you might see me fast forward. Yeah, it's going to take 5 minutes to download this. So we're definitely going to zoom past this part. And we're almost done with the downloading. You can see it's down to 37 seconds. I paused OBS right there while I was waiting for the packages to download. And as we finish there, we're going to be moving on with the rest of the install. So let's wait these 22 seconds that are left over. It's still getting the packages. It hasn't actually gone and installed them, but it should be done momentarily and get on with the install, which should be pretty fast. This virtual machine, I didn't set it up with anything special. You can, if you're planning on using a virtual machine to produce, I suggest that you add some more memory. Here we go with the installing phase. So it's installing now. You should have a lot of memory, probably enable multi-core graphics, probably something that you want, and shared folders. And if you're doing simulation, I would actually encourage you to skip the VirtualBox and go for maybe a dual boot install of Ubuntu next to Windows if you're a Windows user. Just try to get as close to your machine processor as you can. No shortcuts. I'm going to pause a little bit now as the install progresses, and I'll see you back soon. And we're almost done. Here we go, processing the triggers. And yeah, there we go. We installed all the libraries that we need, or the most I can remember. We're going to need another one that I just remembered. So sudo apt install tickle. So basically TCL. What version ships with Ubuntu 22.04? 8.6, right? So we'll go 8.6 and we'll install the development package of that. Let's see if this takes a lot. We'll do another pause. Here we go, connecting to CL, that is Chile archive of Ubuntu. Yeah, it shouldn't take that long. There we go, and we are done. So with this, I just remembered that we need another one, which is we installed, so the commands we've run before, we installed the build essentials, so the build system, G4tran, we're going to need the Fortran compiler, open the basic linear algebra subsystem, but these are optimized linear algebra subsystems. We got CMAKE, which we need for building, and Git, which we need to get the latest source code. We also installed tickle. That was this command that I just issued. And we're gonna need, just to make things simpler for you guys, we're gonna go install CMAKE GUI, the CMAKE GUI, and this should take a little bit more. So it's 54 megabytes. We'll see how fast this goes. I think I'm gonna be pausing it. Yeah, I'm gonna pause it. I'll be back when this is done. Here we're almost done. So in a separate window, I'm gonna look for the latest OpenSees sources, which you can get from GitHub. So just write on Google OpenSees GitHub, and you should arrive at the official OpenSees repo. And I've just copied the URL for the OpenSees code. So I'm gonna copy the HTTPS URL, I think. Yeah, that's the one I wanna go to, because I don't wanna log into GitHub to get the stuff. So let's do Git Clone, and I'm just gonna clone here. And I'm gonna paste that address. You can take a look there and go for the cloning, which should take a little bit. And in this moment we're getting the latest source. So this is not the official version, the official release version. It's going to be actually an unstable version, whichever one is available in the OpenSees worktree right now. So maybe if there's been some latest commit being pushed into the code that might break the build, we might run into some issues, but we'll figure out that as we go. We could, from the same repo, just get the latest tagged version and get an official release version, if we want it. Yeah, this is going to take a little bit more, so we're going to wait here by pausing. There, we're done with the installation, and I'm getting a little low disk space. So was I too... I think I was too... Is this inside the... Yes, it is. It's taking 10 gigabytes. Let's see. Okay, so I'm back. I allocated too little virtual disk space for the virtual machine, so I ran out of disk space after downloading OpenSees. But no matter, I went through the resize in VirtualBox, and now we're back. So where we left is we downloaded the OpenSees source. You should see it in your home directory. So in your home, OpenSees, you should see this source over here. And we're going to be using CMAKE, specifically CMAKE GUI, to do the configuring and compiling of this. So I'm going to open a terminal here. Actually, before doing that, I'm going to create a new folder. I'm going to call it build. Conventionally, it's called that when you use CMAKE. And open a terminal in that new folder. So we're in here, and I'm going to fire up the CMAKE GUI and give it as a directory, input directory, the previous directory. So one up. So we're going to get the GUI here, and let's see where this gets us. So let's start configuring. And over here in this drop-down menu, you will choose Unix makefiles. So CMAKE is going to automatically generate all the Unix makefiles for OpenSees with this. Before, you had to manually write all those makefiles. So no worries, error in configuration project. This is what we need to debug. So let's see what happens here. So it's complaining in this part that we don't have HDF5. So HDF5 is one of the other libraries that we need. So what I'm going to do is I'm going to keep this over here and maybe fire up another terminal. Here, Control Alt T, and go sudo apt install libhdf5, and we're going to install the development version just like that. Input my password and say yes. This should not take that long actually. So we're going to be getting the latest HDF5 library, which is currently needed for compiling OpenSees using CMAKE. So 4 seconds, 3 seconds, 2 seconds, and we are installed basically. So we should configure again after installing that library, and the error should change. We're going to probably get another error, but this is part of the tutorial, how to deal with these errors. So processing triggers, and here we go, configure. Let's see now. So we're getting another error. TCL TK missing. So we installed TCL, so tickle, but we're going to be needing TK apparently too. So let's do just that. I'm going to go here and let's say TK 8.6 -- dev. Let's go for that. Let's see how long this takes this time. And we're going to be going back and forth between installing new libraries and trying to configure OpenSees as we go. And this is how you can get it done. And in other distros, I suspect it should be the same deal. So if you're using, let's say, Fedora or whatever other Linux distro you like, you'll be going between the package manager and the configuration to get everything set up. I don't know about Arch. I don't use Arch. I know there's a lot of Arch users and proud Arch users out there. Let's see if this gets us any further. Okay, so yeah, this is a dependency that I don't understand why it's there, but we do need to have MySQL or MySQL. So let's see. We're gonna need, and I'm gonna need to pause after this a little bit. So let's go for libmysql. I'm just pressing type to see what the autocomplete options are. So libmysql client and -dev. Let's go for that one. Let's see what this does. So SQL, as you know, is a database management library. HDF5 is another type of database. It's actually a scientific computing or a storage format for scientific computing, which is pretty cool, and I use it a lot. Let's go here. So we are still with problems with MySQL. So let's see how we go about solving this. Let's see if I can maybe get some more information on what's going on by tweaking a little bit the window here, so we can use the advanced and grouped options here and see. Let's see, CMAKE. What is it saying here? OPS. Let's find for keys that have something to do with MySQL. MySQL dir not found. So we just installed MySQL, but we did install the client, I think. So let's go for MySQL client. Maybe we didn't have that one, and maybe we need that one. I don't know. I just try stuff out until it works, and this is how I get things done. And most people get things done in this way. So for some reason it needs MySQL, and we're gonna install MySQL related stuff until it works. And again, I don't know why this dependency is there. It shouldn't be there automatically, but okay, we're gonna need to do some more digging regarding the MySQL. Let's see. What else can we try? I can try doing a fresh configure. Let's see if that helps a little bit. Remove everything from here, and then I'm gonna go remove recursive everything so that we have an empty folder, and I'm gonna go CMAKE GUI again and configure. Sometimes this is needed as part of the problem. Okay, so we're getting the same error, so it's a hard error. So let's see. Could not find any package configuration file provided by MySQL with any of the following names. CMAKE did not find this one. So I know we do have MySQL installed. MySQL. What else is there available here? MySQL. I wonder if it's the common one. Yeah, that's installed. libmysql. We installed the client, and what else do we need? Client dev. I think that's the one we installed. So that's the one that's there. So for some reason, it's not finding MySQL. MySQL dir not found. This should be, maybe if we give it a little bit of a push, we'll get through. We should have MySQL. So let's check in the typical Linux folders. So this should be under user. For example, we need lib, maybe MySQL, or lib slash this funny folder x8664, and maybe in there MySQL. No MySQL here. Okay, I'm gonna pause the video, try to figure it out a little bit, and I'll be right back. Okay, so it seems like I made some progress and fixed a little bit of the errors. There's something going on with the MySQL. So here's what I found out. If I go into cmakelist.txt, you can find this file under the home OpenSees folder. And you change the line here that relates to open. So you can take a look at, you can do a search for MySQL, and you'll see that at line 83 you'll find you'll have this line uncommented. So just like this. So if you put a hash there and save and rerun, you can get it working, but then you have to do something else. So I'm going to show you here. If I remove everything, and now I go CMAKE GUI, one step back, and go to configure, Unix makefiles, finish. Okay, here we go. So error in the configuration process. You'll see that the log complains a little bit about, let's see where it's at, MKL. So it can't find MKL, has to do with the basic linear algebra subsystem. Python not found. OpenBLAS, so this one, the one it's complaining. So I had to go in here, and we had to point it where OpenBLAS is. So here under the option OpenBLAS, if this is in red, it's just because it's new options. So if I go configure again, they should all turn white like this. But the error persists, right? So if I go here in the OpenBLAS section and point it to where it is in my system. In my system, Control L to get to the root. I'll go to user. It's not user, but that's what everybody calls it. User local, user lib, sorry, x8664. And here you should have a folder that's called OpenBLAS64, and just point it to the libblast64.so, open, and reconfigure. So after doing this, actually configuring was done. That means I can generate the files, and we'll see what's going on. So it can't generate now. Why? Because it can't find the Python library. So let's go and solve that. Let's see, we should be able to do sudo apt-get install Python. Is it Python dev? Or let's go for libpython dev, something like that. Python, yeah, 3.10, which is what ships standard with Ubuntu 22.04. Let's install this, so the development libraries of Python, and we'll reconfigure and rerun. Yeah, all this installation process, CMAKE is supposed to help out, and I think it does with respect to make files, but it's still not quite plug and play automatic. So I hope with this tutorial you can kind of get a sense of how to debug things. This is a whole world to get into. So I'm hoping some people get something out of this tutorial that can help them along the way to compiling. This should be it. This CMAKE lists file is the main compilation file, and it changes. It's still a work in progress, I think. So that's why we need to tinker with it a little bit. Let's go configure. Let's just generate and see if it throws any errors. Oh, generating done. We're done. So that means I can close here, and I can probably go here and type make. Yes, that's compilation is starting. So we will use, let's see how many cores I assign to this virtual machine. So I'm going to just quickly type system here, system monitor, and I don't think I have more than one. Processes, resources, yeah, I have just one CPU core. So what I'm going to do is just going to make, maybe give it 2 jobs so that it can do a little bit of parallelism, and I'll see you guys in a while when this compilation gets done. If there's something that comes along the way, we'll fix it later. Here I am still compiling. It's been around a minute or so. We're already at 10%, and compilation should continue. I'm sure we're going to come up with some other errors that we're going to have to fix. If not, yeah, that's going to be great. But I'll see you in a little while. We'll see how long this takes. Okay, I'm seeing an error pop up here. It has to do with the SQL. So it's not finding the SQL headers. This SQL stuff is a kind of a nightmare. So I'm going to have to go in and just point CMAKE configure file to where the CMAKE headers are. But before doing that, I'll let this compilation get into, stop at some other error. But it's definitely not going to compile completely. One of the jobs, what this means, it just keeps going, right? So since I added 2 jobs to the compilation, one of the jobs ran into this error, and the other one is just chugging along. So at some point, the other job is going to stop. Yeah, let's allow this to finish, and I'll show you what error comes up after that, and we'll see how to fix the SQL error. Okay, there we go. So it finished building, I guess, down there. The other job exited. We can go up the log and see when it was trying to compile MySQL data store, it was not able to find the MySQL headers. So we're going to fix that. This MySQL data store is basically used when you want to store data in MySQL. I don't know anybody that does that, but there might be some people out there working with MySQL. So let's see if we can fix that. I'm going to bring up the CMAKE GUI again, do a quick preemptive configure, and let's see what's under MySQL here. So it can't find the MySQL header, so the include. So it's looking for the MySQL headers in here. Let's take a look at what's in that folder, and we can see the mysql.h is there. So it should be able to find the header, but for some reason it's not. So let's do some more inspection. We can take a look at what the compile call is actually. Let's see, this embedded library is not found. I've been able to compile without having that, so it shouldn't be that. It's just not including, it's not going into the header file. So what I'm going to do is I'm going to do a quick make like this. This should stop exactly at the same place, but since I'm not putting more than one job, it's gonna stop exactly at the place where the MySQL data store is trying to get compiled. And at that point, what I can do is I want to see maybe the compilation command to see if there's a reason for the link line not to be correct. So sorry, for the include line in the link compiler to be correct. I'm not talking correctly. So when you're compiling, you have to tell the compiler where everything is, the headers for the libraries and the libraries. And there's a -i, an include directive that gets passed on to the compiler that tells it where to look for that, for example, mysql.h library. And if that's not set up correctly, it's not going to compile that MySQL data store. Now, what's surprising here is, as I asked make to compile again OpenSees, I haven't run into the error again. I don't know if we passed the MySQL data store yet. Let's see, maybe not. So we'll see how far this compilation goes, and see if the error pops up again. I haven't. This is strange, but okay. Sometimes compiling is like this. Let's see in a while. Here we go. So the build actually stopped exactly at the same place as before at MySQL data store. If I run make again, what is this gonna do? Okay, so it's gonna stop right there. This is what I want. Now I'm gonna go make and go verbose equals to 1 to see what the actual command that's getting passed is. It's this huge command. So what I'm looking for here is for the MySQL. So these are all the include lines I was talking about. These -i. So this is a folder where the compiler C++ is going to go looking for stuff. So for headers on that tell the compiler how to use certain libraries. Okay. So what I want to look here is MySQL data store. This is the object file that you want to create, and -i include Tickle 8.6 HDF5 serial. So I'm not seeing that that folder being included. So let's see why. Let's see why. I'm gonna go back into that CMAKE lists file. I'm gonna take another look at MySQL. Let's see. Include directories. Look at this one. Look at this guy. So let's uncomment this guy. And I'm gonna also uncomment this guy for good measure. I think we have to uncomment those two lines. Let's save, and we're gonna probably need to reconfigure. So yeah, what if I just run make? What does that do? Because CMAKE will reconfigure. Okay, so CMAKE did reconfigure, and based on that, it's starting the compilation all over again. So you can see we start at 0%. So I'm going to pause the recording again, and we'll see how far this went this time. I hope it went a little bit farther. Here we're back. We're at 60% compilation. I think we've gone a little bit past, we've definitely gone past. So that actually did fix the MySQL issue right there. As you can see, this is involved, but it's not something impossible to do. And hopefully this tutorial will show you the way or help you fix whatever compilation issues you have. Now this is an unoptimized compile. Optimizing the compilation for your system, it's a little bit more involved, and it will require some tweaking. Maybe I can go through that in the future, so let me know in the comments if that's something you're interested in. If I see some demand for that, I might do it. We're not done with the compilation yet, so we might run into some other issue in here. So as we go through this, the other thing is that this is also not a way to compile OpenSees MP, so that's for multiprocessing, for parallel computing. For that, you are forced to use make files at this point in time. So what I'm going to do is I want to create another video. If you guys would like to see that, just let me know again. Just like this video, share it. Hey, here we are. It just finished. So linking CXX executable OpenSees, and yeah, it doesn't like the library actually that we're linking versus. So error adding symbols, DSO missing from the command line. And there's something there that has to do with LAPAC. Okay, so let's solve this issue. Let's see how to get rid of this one. This has to do with dynamic linking. So probably this, we're linking with this SO library. So this is a shared object, it's not a static library. So what I'm going to try to do is I'm going to try to point CMAKE in the LAPAC part. So that's not where we are in the BLAS. Yeah, so this one, instead of pointing it at the libBLAS 64.a, I'm going to go back and take a look at that error. It's coming from libopenblast64.so. So that's shared object. So go back into the GUI. Let's see where it's getting that from. It might be getting it from here, libblast64. Lapack, there's nothing found here, so it's not coming from here. Let's see if we can find all the libraries that have to do with BLAS and see if there's another one. So this is the only one, actually. Let's go for, instead of the SO, which is a shared object, let's go for the statically linked libraries. So the .a, that's a static library. SOs are regular libraries. So configure, that should be good. Configure done, generate. Let's generate, generating is done, and we should be able to compile. And this time the compilation runs faster because it's not going to compile the whole of OpenSees, it's just going to go into the linking phase. And let's see what happens this time. Wow, it's built. So double L, OpenSees, we have our executable. So we're done with OpenSees, the binary, the tickle binding first. And to test whether this is correct, we just capital OpenSees. And here, there we go. If you see this, it's because you already have OpenSees built. And the executable right here was just now created. Cool. Excellent. So now let's figure out how to set it up for it to build the Python library. Now for that, I'm going to go actually into the CMAKE GUI and change the target. So the compile target, I think we can go here. So if you change here the compile target to OpenSeesPy, I think this should work. Let's see. OpenSees final target, OpenSeesPy. Let's generate the files, and let's try to run make again. So it flies through the whole thing because it's already, yes, it's going into the compilation of the Python stuff. Because it's just now only gonna compile everything that's related to Python. You can see it's linking the shared library OpenSeesPy.so, and once we're done, LL will tell you that OpenSeesPy.so is available there. Now if you go and run Python here, Linux or Ubuntu Linux 22.04 doesn't come with a Python command, a dry Python command. You can install this package over here just to make it available. It's just a silly link from Python to Python 3. I can go Python 3 here, and let's import OpenSees. Nothing called OpenSees, OpenSeesPy. How about if we OpenSees, we import the name of the module, OpenSees. Let's take care of the capitalization correctly, OpenSeesPy. And it's going to complain because the dynamic module does not define the module export functions OpenSeesPy. And that is trouble. So I think the way to solve this is actually creating a symbolic link. I'm going to create a symbolic link. It's going to be called OpenSees.so, and it's going to link, it's going to point towards this one over here. File exists. No, wait, am I being correct? So let's do OpenSeesPy.so, and let's point that to OpenSees.so. And now we go into Python 3, and let's import OpenSees, and that actually works. And with that, we are finished. We can use OpenSees like that. Now the reason that happens is because of a little bit of a sloppy setup here. If let's go back here, we have this link that pretends to be the OpenSees library, and the problem here is that the library is being generated with this name, OpenSeesPy.so, but inside this this shareable object, it's telling the Python interpreter that the name of the module should be OpenSees, lowercase, all lowercase, and no py. So that's what it expects. So if I change the name of the file, if I do something else, so let's take a look here. I'm going to remove this link, OpenSees.so, that I just created, going to Python 3, and now if I do import OpenSees, it's not going to do anything. And now look at what happens if I go in here and I rename. So I move OpenSeesPy.so and I call it OpenSees.so, and then I go back into Python 3, and I go import OpenSees. Everything is good. It's able to import that module, and if I go there OpenSees to see the contents inside there, you'll see that all of the commands are available in there. So these are all OpenSees commands that are available inside the OpenSees Python module. This is in Linux, it's going to be used a little bit different than the one you get from Windows. But in any case, this is how you compile this. So history, this contains all the commands that I have run thus far. So I'm gonna store that into a log and go get it log. These are all the commands I've been running since I started. Okay, so this is everything I did. I think you can see I went into gparted. I had to resize a partition in between. You'll see some other things. This is all I did command line wise, and the other edits I did were the ones that are in the CMAKE GUI, or in changing a little bit the CMAKE lists file so that it matches. So I'm going to make this this file right here available. If you want to download it, it's going to be in the link to the description of this video. It's going to link to my personal website, and I'm going to give some instructions there. If you're interested in a cleaned up version, so maybe one where I don't have to poke around and see what's going on to get it to compile, I can also make a shorter video that does that. If there's interest in that, just let me know in the comments, and just like and share this video. Subscribe if you want to see more content like this. Just let me know if this helps anybody out there. I'm also able to do a Spanish version of this. Español, hablo español perfectamente, o no perfectamente porque soy chileno. I am Chilean, so my Spanish is not great. But yeah, if there's interest in Spanish version, I can do that too. So just let me know, and with that, I'll be finishing. See you next time.